So today we are going to start a series of videos on typical problems found on the AP Calculus test. So this is from the 2014 test, the second questions, which essentially is about solids of revolution and cross-section area. If we need a calculator, I will use my Texas Instrument right here, and I'll just write down the answers. At this point, I hope that all of you are good enough about using the calculator that you don't need me to show you every single step for it. Okay, so let's read this problem. Let's try to understand what's going on here. So let R be the region enclosed by the graph of, and we get a polynomial function here, and the horizontal line y equal 4. So this here will be y equal 4. I'll write it down right away. Okay. Find the volume of the solid generated when this region R is rotated around y equal -2. Okay. So we are going to have a horizontal line right here, and the equation of this line will be y equal -2. Okay, and we essentially are going to find that volume here by using a disk. Okay, so in order to get that disk, I'm going to take a random value of x right here between 0 and whatever this is equal to. Okay, I'm going to take a random value of x, and I'm going to draw a vertical line like this from the axis of revolution, which is the horizontal line y equal -2. It's going to meet the first function. I'm going to draw a dot right here. I'm going to keep going up. I'm going to draw another dot. Okay? And this here is going to define a tiny little rectangle, the width of it being dx. Why dx? Because it's in the x direction. Okay, and if we had to find the area of this region R right here, what I would do is I would just calculate the area of that little rectangle like this and go from there. Okay, as it is though, this little rectangle, when I rotate it around y equal -2, it's going to become a disk. So let me draw that again. We're going to have right here the x-axis. Right here, we're going to have the line of equation y equal -2. We are going to have the region R that's going to be approximately this. I don't have a spline feature right here. It's going to be approximately this with an horizontal line right there. And when I rotate that little rectangle like this around the y-axis, that's going to give me something like this. Okay, that's going to give me this here. I'm just drawing half a disk right here. Okay. But really, this disk is a prism, right? And as you know, the volume of a prism is given by the base times the height. Okay, if I were to draw that prism completely right here from the front, if I were to look straight at the x-axis, I would have something like this, right? This will be the x-axis over here, and over there I would have coming straight out of the screen y equal -2, right? And so this distance right here will be labeled as r. If I draw it on this picture right here, this will be my lowercase r, and this distance right here will be my uppercase R, which is essentially this one right here. Okay, so that's what we have here. So what is in the formula above, the formula from pretty much a geometry class, right? This one right here. What is the base? Well, the base right here will be, and I'm going to shade it so that it's easily understood for everyone. This is going to be the base right here. It's going to be the area determined by those two circles, which means that I could say that this base is equal to the area of the big circle minus the area of the small circle. So it will be b pi times big R square minus pi times small r square. So the base right here would be pi big R square minus small r square, like this. Okay. And what would be the height of that prism? Well, the height of the prism, if I look at this picture right here, this is going to be the height of the prism right here. So it's our, basically for us, it's our dx. That means that the volume created by this washer, which we are going to write as dv, is going to be equal to pi big R square minus small r square times the thickness of it, which is dx. Okay, and so you hopefully remember that this here is the formula that you find in most books for the disk method. The question now is, how do we apply that? Okay, so if you look at the picture, and that's the reason for which I would like you to draw nice pictures. Okay, if you look at the picture, the big radius that we have on that picture is going to be the distance between the line of equation y equal -2 and the line of equation y equal 4, as defined in the problem. So big R is going to be 6. Okay, and the lowercase r, look at the picture. I'm going to draw something else. It's going to be this distance here between the x-axis and the first point. So that's going to be this distance right here, which is given to us by the polynomial function, plus this distance right here, which is 2. Okay, so what we're going to have right here is going to be the 2 plus the polynomial function, which was f of x. I'm just going to write f of x for now. Okay, which means that v, our volume of revolution, is going to be the sum of all the dv's as x varies between 0 and that value right here on the picture that we have not defined yet. I'm going to write it, I'm going to call it lowercase a for now. So from x equals 0 to x equals a. Therefore, I'm going to have pi integral from 0 to a of 6 squared minus 2 plus, and right here I'm just going to write the function f of x. So we have x to the 4th minus 2.3 x cubed plus 4. There you go. Now we can see it. So now we need to figure out what A is equal to. So let's calculate A. Calculate A, we are going to do that by essentially saying that it's the point of intersection between the two functions, right? So f of x and y equal 4. So you're going to solve f of x equal 4. And so since this function f of x, let me write it down again for you, x to the fourth minus 2.3 x cubed plus 4. So if we solve f of x equal 4, it's just going to be x to the fourth minus 2.3 x cubed equals 0. And if you factor, you're going to have x cubed, x minus 2.3 equals 0. Therefore, x equal to 0.3. Okay, simple. Now, if that was not a nice, easy to solve problem like this, then what we would be doing is we would be using our calculator to do that. Now, instead of x right here, I need to write A, because that's what we're looking for. This is true for only a specific value of A, which is the intersection. We good? Therefore, our volume is going to be pi integral from 0 to 2.3 of 36 minus x to the fourth minus 2.3 x cubed plus 6 square dx. Okay. Now, I'm not going to do anything at this point. I'm not going to integrate this by hand. Okay. I very much doubt, based on my experience of the College Board problems, that they would expect you to do that on your by hand. So I'm going to use my calculator. Okay. So just to remind you, I'm not going to show you what it looks like, but I'm going to remind you nonetheless. The goal is for you guys to be able to do all of this. I'm going to write under y1 in my calculator, I'm going to write the function y equal 4. Okay, y equal 4. Done. Under y2, I'm going to have x to the fourth minus 2.3 x cubed plus 4. X cubed. And I write x to the fourth already. X cubed plus 4. Okay, so give me a second here. So x exponent 4 minus 2.3 x cubed plus 4. Okay, done. Then what I'm going to do under y3, I'm going to write 36 minus, in parentheses, I'm going to do y2 plus 2 square. That's what I'm going to write. Okay, so 36 minus parentheses y2 plus 2 square. Okay, I don't know if you can see that right here, but that's what I have right here. Okay, just like that. So you might not know how to get the y2 right here on your calculator. It's actually quite simple. On the TI 83 or 84, you just go to vars, which is next to the clear. Okay, then you go one arrow to the right where it says y vars, and then the top option is function. Then you have parametric, polar. So for function, you just press enter, and then you will see all your y1, y2, y3. So you just scroll down to the one you want, and then you press enter. Okay. And then I'm just going to graph my y3. Okay. I'm just going to graph this one For my window, I'm going to be sure that my x minimum is 0, that my x maximum is 2.3, y minimum and y maximum don't matter that much, okay? And so I'm graphing my function, okay? And then what I'm going to do is I'm going to ask my calculator to calculate the area under the curve, basically this area, this integral right here, okay? So I'm going to go second function calc. The seventh option is the integral. The upper limit, oh, I went too fast, I guess. Let's do that again. 7, okay, lower limit is supposed to be 0. The upper limit is 2.3. And that's going to give me the area under the curve. Now, don't forget to multiply it by pi. There is a pi in front of it. So I'm going to do this times pi. And that's going to give me 98.868. Remember, on the AP test, they usually ask you to have 3 values after your decimal points, okay? So let's try to do it the way they want. On my calculator, I got 98.8678899, so just run it like this, okay? So, typical of the AP test, a little solid of revolution problem where you need to use your calculator, right? Now, just one little thing about this problem right here. You see that I wrote a lot of things, okay? I wrote a lot of things because my goal right now is to help you review. Not necessarily to teach that at this point of the year. We are at the end of March right now. I hope that you know how to do that. But to review. My goal is not to just do the problem. If I were to do the problem, I would go a lot faster. I would not talk as much, and I would not spend as much time. Okay, I spent 17 minutes already right here on this problem, which is the time that you have usually for the full problem. Okay, so this here you should be training yourself to do it in about 5 minutes. Okay, so anyway, let's move on to part B. All right, what do we have in part B? The region R is the base of a solid. For this solid, each cross-section perpendicular to the x-axis is an isosceles right triangle with a leg in R. Find the volume of the solid. Okay, so let's try to draw a picture right here. So we're going to have our x-axis like this. We're going to have our y-axis like this. And we're going to have a z-axis right here. Okay, so we are going to have right here parallel to the x-axis. I'm trying to draw it parallel to the x-axis. We're going to have y equal 4. And then we are going to have our function right here. That's going to be tough right here. All right, that's our function y equal f of x. Okay, y equal f of x. I'm going to change the color right here, try to make it a little bit different looking than this. Okay. Now, the cross-section for this problem is a right isosceles triangle perpendicular to the x-axis. So I'm going to take a value. I like pink. I'm going to take a value right here. Let's take this one on the x-axis. And I'm going to create this little line right here. Okay, right there. Now this is the leg of a right isosceles triangle. That means that if I want to draw the right isosceles triangle, this is the other side of it, and it's going to be like that. So this side is congruent to this side. This is a right angle. Okay, And of course, this is just an area. We want to create an elementary volume, dV. So I'm going to have a tiny little thickness right here. Okay. And this here is going to have a volume dV. Now, this volume dV, this tiny volume is going to be equal to the area of this triangle times dx. Okay. And for now, I'm going to call the side of the triangle, the leg, I'm going to call it L, L for leg. So we have the leg right here, we have the leg right here. Now, would you agree that this right isosceles triangle, it's like a square that is cut in its diagonal, right? So that's going to be the area of a square divided by 2. The area of the square will be L square. Okay, so our dV right here will be 1/2 of L square dx. Okay, and what is L in this case? Well, L is essentially the distance between this point and this point. So L, I would say, is equal to 4 minus f of x. Would you agree? All right, let's go back to the original color. That tells me that our volume, which is the sum of all our volumes, elementary volumes as x goes between 0 and 2.3, will be equal to 1/2 integral from 0 to 2.3 of 4 minus f of x square dx. Okay, so what does that mean? Well, that means that on my calculator, what I'm going to do really is I'm going to go to y4. Okay, remember, we can see on the screen, we have y1 equal 4, y2 equal the function, y3 equal what we needed for part B, right? But for y4, I'm just going to essentially write 4 minus y2. Then I'm going to square this, not y square, y2. Square like this. That's all I'm going to do. Okay? And then I'm going to use my calculator to calculate this. So let's do this. Y equal. So first I'm going to unselect my third function, and then I'm going to have 4 minus y2. 4 minus y2 exponent 2 like this. Okay, I'm going to graph it. There you go, my calculator is doing it. Then I'm going, as before, to calculate the integral. Lower limit will be 0, upper limit will be 2.3. There you go. And then I don't want to forget to multiply that by the 1/2 in front. And that gives me V equal 3.574. Okay. So just like in part A, when you were asked to find a volume of revolution, we started with this here basic idea. This here is essentially the formula for the volume of a little washer. Okay. Here we started with this formula right here. This is the formula that you need to use for a volume of cross-section area. The elementary volume is equal to the area of the cross-sections times the thickness. So if you're told that it's perpendicular to the x-axis, it's going to be dx, and if you're told it's perpendicular to the y-axis, it's going to be dy. Be careful. Most of the time they don't try to trick you with that, but if there is a perpendicular to the y-axis, I remember an instance a few years ago when it happened, make sure that you have a dy right there. Okay? All right, part C, it's not a typical question for part C right here. Let's read it together. The vertical line x equal k divides R into two regions with equal area. Write, but do not solve. Now, this part is common. Write, but do not solve is common. An equation involving integral expressions whose solutions gives you the value of k. There are many solutions, okay? But let's draw a little picture to make sure we understand what's going on here. So I'm going to have my y-axis. I'm going to have my x-axis. I'm going to have my y equal 4. And let me change color to draw the function. We're going to have the function that's going to be somewhat like this. Okay. And so we have a line y equal k. It's at x equal k or y equal k? That's very different. X equal k, yes. X equal k. So we have a line of equation x equal k. So let's do this here. X equal k. Like this. X equal k. That split the entire area into two equal parts. That means that this part right here will be equal to this part right here. Okay? And remember, over here we are at 2.3. So we have different ways of doing it. We could say that in order to find not x equal 4, why did I write 4? It's k. My brain sometimes is weird. X equal k. Okay? So here's what we can do. We could say either the integral from 0 to k of 4 minus f of x dx, which represents the left side of the x equal k line, equal the integral from k to 2.3 of 4 minus f of x dx. We could do it like this. That's option 1. And I'm pretty sure that this would be perfectly acceptable. Option 2, we could also say that the integral from 0 to k of 4 minus f of x dx is equal to 1/2 the integral from 0 to 2.3 of 4 minus f of x dx. Okay? So you have different options right there. But since here the question is just about setting up the problem and not solving it, essentially we can conclude that we are done with this one. Okay? So again, this problem right here is number 2 from the 2014 EPI test. I would like to encourage you to go on the College Board website, look at their rubric, the rubric that they use to grade all of this. Hopefully I didn't make a fool of myself and make mistakes, right? And see what they expect for this problem, for your solutions at least. Okay? All right, that wraps it up for this one. And I'll see you later for a different installment. Take care.